Hello and thank you very much for joining. In this lecture, we are going to go through our cloud architecture, which we are going to build with the help of Terraform in order to deploy our website. But we'll do this at a very high level. We'll do deep dive about all the components in relevant section. So let's begin. We are going to deploy our resources on AWS Cloud as we discussed in the case study section. AWS has multiple regions around the world, and we are going to deploy our website and associated resources in the EU West 1 Ireland region. Now the reason to choose this region is that it is one of the oldest and one of the most mature AWS regions. It has all the services we need for our project, and I would highly recommend you to use this region if you are following along. Within this region, there are multiple availability zones, and we'll be deploying our resources in EU West 1A and EU West 1B for our project. To begin with, we'll first create a new custom VPC, which will provide us a logically isolated section of the cloud for our project. Once VPC is created, we'll attach an internet gateway so that our VPC can have access to the public internet, as our website is a public website. After that, we'll create multiple subnets within this VPC. There'll be 2 public subnets and 2 private subnets. The reason for this is that for security purposes, we would like to deploy our application and storage resources such as database into private subnet, and public subnet will provide necessary access to our private resources in a secure way. We'll go into more details about this in later sections. Once subnets are created, we'll deploy a NAT gateway in public subnets, which will allow internet connectivity for our private subnet resources in a secure way. We'll also launch bastion hosts in public subnets to allow SSH connections to our private resources if required. In the private subnet, we'll create 2 autoscaling groups spanning across our both availability zone, front-end autoscaling group and back-end autoscaling group. The idea behind this is that with the help of ALB and target groups, we'll send our customers or site visitors to the front-end autoscaling group and direct our admin or back-office users to the back-end autoscaling group. The reason behind this is to separate 2 different types of traffic and create that separation of concerns, which will increase the reliability of the site. Since admin users are more resource heavy, as we learned in the case study, giving them a separate autoscaling group will help to avoid any adverse impact on our front-end users. The other point I would like to mention is that this is generally a good real-world practice, as in our case we just have the admin site, but many enterprise-level production websites use multiple complex back-office processes such as cron jobs, API interaction, etc. And this separation of concerns become even important in such environment. In private subnet, we are also going to launch our RDS for MySQL database instance with multi-AZ configuration to increase availability for the website. As if failure occurs in one AZ, standby instances can take over and our website will remain functional. We are also going to launch Elasticache for Redis instance in multiple availability zones, where one will be our primary node and second will be a replica, which will take over in case of any failure. This again will provide high availability to our website. Redis will provide in-memory caching to speed up our website and store user sessions. Our autoscaling groups will use caching to reduce the load on our DB by caching frequent database queries. Also, without storing user session to Redis, we won't be able to use our autoscaling groups. We'll cover this in more details later. Finally, for our autoscaling groups to work, we'll need shared storages for media files. We are going to use the Elastic File System for that. We are also going to use AWS Certificate Manager, CloudWatch, S3, and AWS Code Commit for our project. Okay, so this is our architecture, and let's now talk about our traffic flow. Here we have our site visitor or our back office user trying to access admin. Once the user types domain in the browser, the browser will ask for IP to route 53, where we are hosting our DNS for the domain. Route 53 will supply CNAME for the application load balancer, which will resolve to the public IP for our application load balancer, and the user will be sent to our LB via Internet Gateway. Once we have completed this architecture, to further enhance the performance of the site, we are going to do a few more steps. We are going to introduce AWS Cloud front distribution to cache our static media sets, which will improve the site load speed. Right, so there are a lot of interesting things we are going to complete within this project, and I'm confident that in the process you are going to learn many exciting, high-in-demand cloud technologies, which you can implement in real-world scenarios. I have attached the full diagram in the resources section if you would like to download it and keep it as a reference. It'll be also useful if you're following along. So let's conclude this lecture here, and I'll see you in the next one. Thank you very much for joining.